Hi everyone! In this video I'm going to show you how to graph quadratic inequalities in two variables. And so we're basically going to do the same process we would for graphing quadratic equations. The only real difference is we're either going to do a solid line or a dotted line, depending on whether or not it can be equal to or not equal to the quadratic, depending on our inequality sign. And then we're going to shade the region above or below the quadratic. So I guess the quadratics you can graph in lots of different forms. You could use completing the square to turn standard form into vertex form and graph based on vertex form. Or if you can get factored form, you can just graph based on factored form. For the sake of this video, I'm just going to show factored form just because it's a little bit faster. But the regular graphing principles for quadratics that you'd use for graphing any quadratic, you can use for graphing an inequality. It's basically just the very last step that changes slightly. So without further ado, let's jump into an example. Let's do 40 minus y is greater than negative x squared plus 13x. Now, there are two ways we can solve this equation, or isolate y, I guess I should say, in this equation. Usually you want y equals when you're graphing, and so same thing with inequalities. You want y on its own on one side of the equation, generally speaking, when you're going to go to graph it. So I've got negative y on the left-hand side. And because we're dealing with inequalities, negative y's we kind of don't want to deal with, because when you multiply or divide by a negative, you actually need to flip your inequality. So if you notice that, and if you're cognizant of the idea of having a positive y value, one way you could solve this would be to bring your y value over to the right-hand side, right? So you'd have, like, on your right-hand side, you'd have y with the less than sign pointing towards it. And then your right-hand side, then you dump all of your other x stuff to the other side. That's one way to do it, that's fine. But I haven't shown in a while multiplying or dividing by a negative, so I'm going to show it the other way, which is getting rid of the 40 in the first step. So we have the y with its coefficient on its own. So minus 40 to both sides leaves us with negative y is greater than negative x squared plus 13x minus 40. Now, I don't know about you, but I can't really graph negative y's very well. Like, if negative y equals something, what does that mean for graphing? I don't know. That's like confusing. So let's just get rid of that negative sign. And the way you get rid of the negative sign is by dividing. Now, I'm dividing by negative 1, which like you should have like klaxons and alarms going off in your head anytime you're multiplying or dividing by a negative sign with an inequality, right? And why is that? Well, what are we going to have to do with our inequality? We're going to have to flip it to be the other way around, right? And just, y, if we've got 2 less than 3, okay, good, we agree with that. If we multiply both of these by negative 1, we get negative 2 less than negative 3. Negative 2 is not less than negative 3. Negative 2 is greater than negative 3. You actually have to flip this to be the other way around when you multiply or divide by a negative. Okay? So in this case, because I'm dividing by a negative, I flip my inequality. Then everything else can just stay, just be the usual way. So all our negatives are going to become positive. So negative x squared becomes positive x squared, and positive becomes negative, and negative becomes positive. Now this one looks like it's going to factor really nicely for us, and sure enough it does. This is going to be two things that multiply to 40 and add to 13, and those numbers are 8 and 5. 8 times 5 is 40, and 8 plus 5 is 13, and since it's a negative, we're just going to put negative and negative there and there. Okay, now that gives us our two x-intercepts. This gives us x equals 8 and x equals 5, the two zeros of our quadratic. So if I was graphing a quadratic at this point, I'd sketch my x-intercepts, throw my line, and call it a day. The difference here is that we actually want our less than symbol, so we're actually going to graph our quadratic slightly differently. So we're going to, sort of start in the same way. There's our 0, 0. This is our y-axis and our x-axis as usual. I'll put 5 here and 8 here. And we have a positive a value, so our quadratic is opening up. But when I sketch my quadratic, because it's less than, it's not equal to. So I do not want a solid line. My opening up quadratic, I'm going to put in with a dotted line. So that's my dotted line because it can't be equal to. And I want y less than this. So where is y less than this? Y is less than this everywhere below our function. And so this is the region of y less than x minus 8, x minus 5. Okay? And this line itself is the line y equals x minus 8, x minus 5. Okay, so then in terms of solutions, like sort of any point in this region would be a part of the solution of this quadratic inequality. Okay, let's try one more. Too much fun to just do one example, right? So y plus 30 is greater than or equal to negative x squared minus 11x. So in this case, our y is positive, so we're just going to want to leave it on the left-hand side regardless. Everyone probably is going to do the same first step. Our positive 30 becomes negative 30 on the right-hand side. Now, what's the problem with factoring this right-hand side is we've got a leading negative coefficient. And so like a really, really good sort of hack, anytime you've got a leading negative coefficient, is just get rid of it. Common factor it out. You really want to have positive leading coefficients when you're factoring. It makes the factoring step a lot easier. So this gives us x squared plus 11x plus 30, and 5 times 6 is 30, and 5 plus 6 is 11. So we can factor this really nicely, x plus 6, x plus 5. So this gives us zeros. X equals negative 6, x equals negative 5. So I'm going to sketch that. Those are really close together, so I'm going to do a really exaggerated. You notice I don't really care about my y-axis, like I'm including my y-axis, but I don't really care that much. Oh, what am I talking about? I need negatives. I'm including my y-axis, but I don't really care about my y values much. I'm just doing a quick sketch on the x-axis. So I'm going to make my points a little bit exaggerated so that I've got room to show the quadratic between. And since it's negative, it's opening down. So my quadratic, when I graph it, is going to be opening downwards. And why am I choosing to do a solid line for this quadratic? Solid line in this case because it can be equal to. And I want y greater than or equal to this thing. So my region is everything above the quadratic, right? All the way up to positive infinity. Okay? And that is how you sketch a quadratic inequality in two variables.